This video lesson will teach you about molarity. Molarity is a way to get moles of compound from volume of solution. Unlike solids and liquids that we can weigh and use the molar mass to calculate the number of moles, solutions are given with concentration in units of molarity. You have to be able to get from the volume of solution to the number of moles of compound present in order to use solutions in stoichiometry. The notes to go with this video lesson are on page 18 of your Unit 3 notes packet. This video lesson will cover Learning Goals 16A and 16B, which are both Unit 3 objectives. Remember that when we were discussing the conductivity of solutions, we decided that the key to comparing two solutions was looking at the number of ions per volume of solution. Molarity is a unit of concentration that allows us to easily look at how many molecules, formula units, or ions are in a given solution. Remember that chemists prefer to count in moles rather than individual particles, so it should stand to reason that even when we're counting particles in solution, we still want to count those particles in terms of how many moles are present in a given volume of solution. Molarity tells you the number of moles of solute per liter of solution. Remember that solute is the substance that's dissolved into a solution. Molarity is given the symbol capital M and is calculated by taking the number of moles present and dividing by the number of liters of solution. We're just going to try some examples here of some problems you can solve using molarity. So for our first one, I want you to remember the dissolving compounds experiment that we did as a class with the light bulb. We made a number of solutions that had 0.5 grams of solute dissolved into 50 milliliters of solution. One of those solutions was the bluish copper chloride solution. I would like to find the molarity that we get for copper 2 chloride when we put 0.50 grams of copper 2 chloride into 50 milliliters of solution. So for my information, I have my 0.50 grams and my 50 milliliters of solution. Since this is a molarity problem, I'm going to need my molarity equation. Notice that molarity is moles per liter, but at the moment I have grams and milliliters. That means back in the information step, I'm going to need enough information to turn the grams of copper 2 chloride into moles, and enough information to turn milliliters into liters. So I need the molar mass of copper 2 chloride, which I can get from my periodic table, and I need to know that there are 1,000 milliliters in a liter. So my plan is then going to be to turn the grams into moles, turn the milliliters into liters, and then take the moles and divide by number of liters. So we'll start with our 0.50 grams of copper 2 chloride. And we'll use our normal moles to grams to moles conversion. Keeping two significant figures, I figure out that I have 0.0037 moles of copper 2 chloride. Then we'll take the 50 milliliters of solution, use our conversion factor between milliliters and liters, and determine that we have 0.050 liters of solution. I have to keep the 0 here because of the decimal point present in the 50 milliliters over here, so that I start with two significant figures and I end with two significant figures. Remember, leading zeros aren't significant. To calculate the molarity, I simply take the moles of copper 2 chloride, divide by the liters of solution, and I find out that my solution has a concentration of 0.074 molar. The other thing you can do with molarity is to figure out how much of a compound is present in a given amount of solution. In this scenario, we're asked to figure out how many grams of sodium chloride we will get if we take 950 milliliters of a 0.81 molar sodium chloride solution and evaporate all the water. So I know that I have a 0.81 molar solution. I have 950 milliliters. Keeping with our general theme here of using molarity is equal to moles per liter, I decide that the way to go here is to solve for the moles of sodium chloride. If you look at what we have, we're given the molarity and we're given a volume. And if we use those two pieces, we can find our moles of sodium chloride. But before I can do that, my amount of solution was given in milliliters. I'll have to convert it to liters. And when I'm all done, since I need to get to grams of sodium chloride, I'm going to have to take the moles of sodium chloride and convert to grams. That's going to require the molar mass of sodium chloride, which you can get from the periodic table, and again, this conversion of 1,000 milliliters being equivalent to a liter. So in order, my plan is that I'm going to take the milliliters and turn it into liters, plug the liters and the molarity into my equation and solve for moles, and then in the end, take my moles of sodium chloride and turn it into grams. So starting with my 950 milliliters, I'll convert that to liters, keeping these two zeros because they were significant in the 950. And now I'm going to plug all of this into my molarity equation. This is the molarity I was given. This is my volume expressed in terms of liters. When I do the math, X is equal to 0.77 moles of sodium chloride. In the context of doing stoichiometry, we actually will often stop at this point, because often for stoichiometry, all we really need to know is how many moles we have present of any particular reactant. This problem, however, asked us to continue forward and figure out how many grams we have. So to do that, we will just use our molar mass, and we can figure out that we have 45 grams of sodium chloride present in 950 milliliters of a 0.81 molar solution. This example we will deal with as a whole class, so don't worry about this one at this point in time. We just need you to practice a little bit with the basics of molarity before we figure out how we're going to use this to predict things like conductivity of solutions.